I'm doing Year 5 Light Reflection and Refraction, and we'll first start off with a recap of what we learned from last lesson, and then we'll go into an introduction into reflection and refraction, where I'll do some hands-on demonstration to show the students how it works in real life. And then we'll split off into 2 rotations where they get to do their own hands-on demonstration of reflection and refraction. And then I'll finish off with an exit ticket and summarize what we learned for the day. 1, 2, 3, eyes on me.
1, 2, eyes on you.
Thank you, Year 5. All right, I'm gonna start off with the role today, and I want you to describe how you're feeling in just one word. Are you ready? Beautiful. Caitlin.
Good.
Amazing. Abby.
Excited.
All right, awesome. Sounds like we're ready for a fun science lesson today. Let's do a quick recap from what we learned from last week. So, we know that light travels in a
straight line.
Amazing. And we know what are some light sources that we learned from last week. Abby. Oh, do you want to ask a friend?
The sun.
The sun, amazing. And Caitlin?
A light bulb.
A light bulb. Yes, good job. Just like my torch here. And we know that if I have this light pointing at my whiteboard, when I put my hand in its beam path, what does it create behind? Yes, Caitlin.
A shadow.
Amazing, it does. Because we know that the light is being blocked. It's not going through, it's not going up and down or around. It's traveling in that straight path, being blocked and creating that shadow. Amazing work. So today we're going to be learning about 2 new concepts, reflection and refraction. Has anybody heard of reflection before? Yes, Abby.
Like in the mirror?
Yeah, in the mirror, we look into it and it reflects our image back. Good work. Any other reflection things that we may have heard before?
I've heard the word, but I'm not too sure.
No, that's okay. We know that sometimes in the water as well, we can see our image being reflected back because they have reflective qualities. All right. So that's what we see in everyday life in reflection. So we know that mirrors reflect our image. What do we think will happen if I shined my light beam into a mirror? Will it be blocked and create a shadow like it did when we learned from last lesson? Or is there another idea you might have on what it could do? Yes, Caitlin.
Well, because you said mirrors reflect image, would it reflect the light as well?
Ooh, I like where Caitlin's thinking. All right, let's use some scientific vocabulary. So we go, I predict the light will
reflect in the mirror
because
it is reflective.
Yeah, we're on the right track because it has reflective qualities. All right, let's have a look. I've got my light. I'll try not to shine you in the eyes. Let's do it against the wall so we can see if it, oh, you probably can't see, but it is reflecting on the whiteboard. It is reflecting, it does, good job. So our prediction was supported by the little experiment we just did. All right, can you grab out our science books, please? And go back to our last week when we did light, shadows, and where sources come from. And I want you to write down reflection in your books. Beautiful. And can you please write a definition for reflection, light reflection, bouncing off surfaces, causing a change of direction. So I'll write it on the board and feel free to copy. All right, now let's have a deeper look into reflection. So I have built us a little one-way tunnel. We know that when I shine my light through this tunnel, it comes right out the other end. Thumbs up, sideways, or down if we understand that concept there. Beautiful, because we know that light travels in a straight path. So we know it's going to go straight through my tunnel here. We know, let me know if you can't see this little demonstration. We know that if I create an L shape here and shine my torch through, it's getting blocked by this wall. It's not bending on its own to exit the tunnel because light cannot bend on its own. So I want one of us to have a go and maybe putting a mirror in the corner to try and reflect it out. Any volunteers? Yeah, come on up. All right, I'm gonna have the light off for this. So place the mirror where you think it needs to be to reflect the light out of the tunnel this way.
Like there.
All right, you hold it there and I'll turn it on.
Ooh.
And then let's see if it's coming out of the tunnel. Oh, it is.
It's over there.
It's a little bit off, but it is coming out. And you're right. And as you can see, you're angling it because we need to get the right measurements and the right angles to project the light out of the tunnel. Amazing work. Thank you for volunteering. All right. So to recap, we know light cannot change direction on its own, but it can be reflected, my bad, students, to change. That's how we get it out. Has anybody ever seen a periscope before? The ones you look in and the mirror reflects out and you can see in a different direction, like what spies use in tunnels? Yeah, kind of like that. All right. We're gonna move on to refraction. Hands up if you've ever heard the term refraction before. No? That's all right. It is a bit of a new word, but I really want to get our science vocabulary up. So, I have an arrow. What way is it pointing?
To the right.
Beautiful, it's this way. Now, if I put this arrow in line with this glass of water, what have you observed happening?
The arrows flip directions?
Yeah, the arrow should have changed direction. Beautiful. That, year 5, is light refraction, because light is traveling from one medium, air, into water and changing its direction because it's going faster through the air and then slows down in the water to swap it around. So, I want you to think, pair, share possible real life experience where we see refraction. Have you seen it anywhere where light has gone through 2 different see-through materials and changed and bent? Have a think, pair, share with your friend. It's all right if you're not sure.
Have you seen anything, Abby? Yeah, sure. I'm trying to think as well, but nothing's coming to mind at the moment.
All right, so it sounds like we're not too sure, which is all right. This is a new concept. Have you ever put a pencil in a glass of water and seen that it's a bit disordered, it's a bit bent? That's light refraction. I'm not sure if you'll be able to see there. It's probably a little bit hard because we're so far away. But that bending and distorting, that's light refraction. All right, can you please write the new heading, light refraction, in your books? And I want you to copy this down. Light refraction is the bending of light as it passes through one transparent medium, in brackets air, to another, in brackets water. I'll write it on the board so you have time to write. Beautiful. Okay, now I'm going to split you guys into 2 rotations. The first group will be doing light reflection experiments where you're going to design a maze. I will come and approve of it. It has to have at least 2 bends because you're going to predict where the mirrors should go to reflect the light out, like a maze. Now, if you don't get it right the first time, that's good because we want to do a guess and error, trial and check, you know? Bend the light, angle them a little bit different so you can see how it gets out. And the refraction group, you're going to test putting objects in water to see what way they bend, and if you put it in directly straight, will it distort? Is the light refracting? All right, before we begin, a few safety checks. Do we shine the torch in people's eyes? No, we don't. We keep it pointed down, or you don't need to have it on. We're not playing with it, it's not a toy. If you knock the clear glass over, what's the first thing you do? Clean it up or let me know. We don't want any cuts, okay? That's why we wear our closed-in shoes, so it's not dangerous. All right, and when you're cutting cardboard and things, use the scissors safely. Don't go running around with them. All right. I'll split you off into groups now.